Welcome to Algebra 1, Semester 2, Unit 10, Section 8.6. Okay, we have a couple items here that we want to look at. We're still working with the exponential growth and decay. First thing is that T in these formulas, T represents time period. So if I tell you it's over so many years or whatever, this T is our time, okay? Your initial amount is equal to A. That A is our initial amount, okay? Now, a couple other just important vocab terms to have as we're working through this so that you and I can talk about things and be clear on what's happening. Your growth factor will be 1 plus R, and your decay factor, so that's your growth factor. Your decay factor, because it's going down, will be 1 minus R. Okay? So that's your decay when it's minus, growth when it's added to it. Your rate, decay rate, is the R value that we put in there. Your growth rate is the R value that we put into that formula. Okay? So, let's look at a couple of these. First off, there's a typo. I have them both labeled as decay. You can look at which would be decay here. It has to do with this factor right here. This is your growth or your decay. Do you notice how growth would always be bigger than 1? And decay would be less than 1. So which one is growth and which is decay? This is 1/3, that one's 3. If you said that this one's growth, you're correct. Go ahead and fix that typo. Now we're just going to compare another typo, not linear functions, but rather growth and decay functions. Okay? So take each formula and fill it into the T-chart. So this first one, that's another typo. We're going to take -2 and put it in here for the exponent. So we have 3 times 1/3 raised to the -2nd. Now remember, with the negative exponent, we flipped it, so that would become 3/1 squared, which would be 9 times 3 is 27. 3 times 1/3 to the -1st, we would flip that 1/3, so it would become 3 times 3 is 9. 3 times 1/3 to the 0th, 1/3 to the 0th power. Anything to the 0th is 1, so that will be 3. Now you can start to see the pattern where we're decreasing by a factor of 3. So you could predict 3 divided by 3 would be 1. 1 divided by 3 would be 1/3. Let's make sure that that works. 3 times 1/3 to the 1st power. 3 times 1/3 is 1. 3 times 1/3 squared, well, that would be 1/9 times 3 would be 1/3. So if we go to graph this, which is the next thing that I ask you to do, have our XY axis. Again, I apologize that these graph lines are so light. I didn't expect that from the copier. Okay, so at -2, we're way up at 27. It's clear off the graph. At -1, we're up here at 9. At 0, we're at 3. At 1, we're at 1. And at 2, we're at 1/3. So we can start to see our curve. And that is a decay. Notice how the curve's going down over time. Time going to the right. Now our growth function, you might predict what's that going to look like down here. If decay ended up dropping as it went to the right, what do you think growth would do? Let's see if you're right. 1/3 times 3 to the negative second. 3 to the negative second would get flipped to the bottom. That would be 1 over 3 squared, which is 9. So 1 over 9 times 1 over 3 would be 1 over 27. 1/3 times 3 to the negative first. Well, 3 to the negative first would be 1 over 3 to the first, which is 1/3. 1/3 times 1/3 is 1/9. 1/3 times 3 to the 0th. Anything to the 0th power is equal to 1, so that's just 1/3. So it's 1/3 times 1. 1/3 times 3 to the first, well, now we'll reduce, because 3 times 1/3 is equal to 1. 1/3 times 3 squared, that would be 9 times 1/3 is 3. Now if we went one further, 1/3 times 3 cubed, that's 27, that would be 9. So we'll just plot that one as well. So over here at -2, we start at 1/27. I can't even mark that, that's so close to 0. At -1, we're at 1/9. At 0, we're at 1/3. At 1, we're at 1. So if you notice, these first few lines could almost be looking like they're linear, but just keep going. At 2, we're up here at 3. See, we just started into the curve now. And at 3, we're up at 9. So if you go just far enough, you'll see that curve develop. But be aware that they can look that way, and that was a growth exponential function. Okay. Next page. Page 8. In the decay graph, for each unit to the left of the axis, how many units does it decrease? Okay, so if we look at our decay graph from the page before, they're asking how many units does it decrease as it's coming across here? Well, it's decreasing greater than 1 unit. In the exponential growth, for each unit to the left of the axis, how many does it increase? For the growth, it's increasing less than 1 unit. Now, the one thing that I'd like you to do is go back and put the factors on these, even though I'm asking the number of units. So for decay graph, the decrease, I want you to make sure and write that it was 1/3 factor. We're cutting them in thirds. And on the growth, it's a factor of 3. We're multiplying them by 3. In the formula, y equals ABX, which letter represents the growth or decay? If you said B, you are absolutely correct. Can you tell, looking at a function equation, whether it is growth or decay without graphing it? Yes. Growth, the B value. Remember, the B value on growth is greater than 1. Right there, the 3. So the B value is greater than 1. And decay, the B value from our formula is less than 1. Or from our graph that we did, is less than 1. So B is less than 1. They cannot be equal to 1 or there's no growth or decay. It's just a straight line. Then you come back to being linear. Determine if the given function is exponential or linear, and then write the rule to fit the function. Well, as we go this way, we're dividing by 5, which is the same thing as timesing by 1/5. Divide by 5 times by 1/5. And it works for each one. So we know that it is exponential. Now I would like you to write exponential decay. Because then you're telling me, I know that this b factor is 1/5, it's smaller than 1, and my starting amount was at 1, or at the y-intercept. Okay, next one. I have 4 to 2, that would be divided by 2 or cut in half. 2 to 1, 1/2. 1 to 1/2, 1/2. 1/2 to 1/4 is a half again. So we have the rule of 1/2 raised to the x. Here's my starting number. So there's my rule. And this was an exponential decay too. Next one. Looks like we're cutting in half again, except that we go to 0. I don't know if you've noticed, but the exponential functions don't go through 0. So this must be a -2, -2, -2. What is this function? This is, if you said linear, you are right. Linear or arithmetic sequence, same thing. Now, the -2, remember, from yesterday's lesson, is our slope, so it's a -2x. There's our y-intercept plus 0. Or you could just put -2x. Wouldn't have to put the 0. That is almost the end of the lesson. You're going to come to class tomorrow and model a exponential change. Doesn't mean that you're getting up and modeling. You're actually getting some materials from me, and you're going to do this little activity. Feel free to use a lab partner with you, and then you'll be attaching a sheet on that. And you won't have bookwork tomorrow on that section. You will have some bookwork for practicing those, but I want you to do the activity first. Make sure you really understand it. See you tomorrow.